Firstly, you need to understand the concept reactions. By the reaction, we're simply meaning that this is the chemical process whereby the substances they act um, mutually to each other, or they are changed into different substances. Ne? One substance changes to become another substance. So that's basically um, the meaning of the reactions. Then under those reactions, we are going to look at different four types of the organic chemical reactions. And I believe everyone knows those four general types of organic reactions. The first one will be looking at the substitution reaction. The second one will be looking at the addition reaction. The third one will be looking at the elimination reaction. And then fourthly, they are saying that we're having the rearrangement organic reaction. And you also need to understand how are the reaction occurring. We need to know the mechanism of these reactions. How are they occurring? Okay, so that's basically the mechanism of its or of the reaction. So on our first one, as they've already indicated, we're going to look at the substitution. Under the substitution, they're saying that this is the chemical reaction in which an atom or a group is simply replaced by another atom or group. An atom or a group is simply replaced by another atom or a group. Guys, can you please make sure that your mic is off that side? Those who just joined the meeting now, make sure that your mic is off. So in this case, we will be looking at the replacement of the atoms or the group. If you can check here, we're having a group which is OH. This is an alcohol group, right? So it reacts with what? With HCl, and then it forms this compound. So if we can check the Cl here, which is chlorine, it has replaced the OH. Okay, it has replaced the OH here as the group, and then it became Cl in this side of the product. So in this case, we're going to classify it under the substitution reaction. One group was replaced by another atom. Ne? Then we're going to move to the next one, which is the addition. Addition is the reaction in which the atoms or the groups they add across the double or the triple bonds. So in this case, usually the addition reaction it occurs in the double bonds and also the triple bonds. So if you can check here in the first, we're having the C, and then in between we're having the double bond and also the C, two carbons, right? And then it reacts with what? It reacts with water. And then we are also having your formation of the product, and then your conditions, they show you the what? They show you the hydrogen atom there. Okay, so let me see the message. No, the session is for both modules, because I said that you must join the meeting for both for SHM today, because you said that you're also doing these things in SHE. That's why I shared the link also in your group. I hope I'm clear. So can you see here?
Yeah, merile abo ya nyangatsa dita. Phela mfata ngare sonje vanhu vantima nga ra ya kotinchi phela nto vanhu vantima swi ri blind ball sanje so va tirhisa mirhi se munhu jaso so tshamiseka n'wantu.
Guys, can you please switch off your mic because you're making noise now. I said that whenever you enter the session, please make sure that your mic is off because now we have to listen to you, that side, and it's not fair. So let's respect the session. So if you can check there, and then we're going to break the double bond that we have this side, then plus with water, and then the water will split because the double bond is now broken. And then this side we're going to have the formation of H. The H atom is going to be in this case, and then here we're going to have the OH group. So that will also even in the same place as when we were talking about the in a case where there is a triple bond, the same procedure is going to happen. Let's hope that maybe we will get to the example whereby we're gonna have the triple bond as an example. Then on the next one, we're having elimination. So basically the elimination, I take it as the what? As the opposite for addition, okay? Because in this case, we are going to form the what? The double bond or the triple bond. The atoms of the group, they are removed from the adjacent atoms. The removal from the adjacent atoms, which is OH and H, you see, and then we're gonna form the what? The double bond here. And since we have broken our what? We have removed our adjacent atoms to form our triple bond, meaning water is going to come this side. But with the addition, can you see here? We're having the what? We're having water here as our product, I mean as our reactant, reacting with this compound of double bond, and then to form a single bond, okay, across there. Yes, to form a single bond. So that's why I'm saying that if you can check with this one, is the opposite of whatever you did in the addition. I hope you understand. So you must know that the addition and the elimination, basically they show the, or they explain the the opposite against each other. Then now we're having the rearrangement. Okay. The reactions in which the rearrangement is the reaction in which a single molecule, it undergoes the reorganization. Meaning when when we are saying we are rearranging something, meaning you are moving it from its original state, and then you arrange it to other form of state, from the original state into another thing. And then this is the reaction in which a single molecule undergoes the reorganization of its bonds and the atoms to yield the isomeric product. So basically, when they say that it undergoes the reorganization of its bond and atoms to yield isomeric product. So meaning whatever that we are going to get, those bonds, or they are going to be arranged in such a way that they form an isomeric product. You know the isomers, right? From chapter 1 already talked about, I mean, from chapter 2, we did the isomers. We were looking at different isomers. How do they look like? Ne? So in the rearrangement, if you can check here, you are having ethene here, and then here you are having a hydrogen atom, right? Focus on the red ones, on this red compounds and atoms. And then under the process, I mean, the reaction undergoes under the aid of the acid catalyst. And then they're saying that is one butene, the IUPAC name of this, one butene. And then when it comes here, and then it's gonna change. Can you see it here? This was your branch here, right? CH3, CH2, and then it's gonna be rearranged. So the CH2 is no longer going to be in this side. Then it's gonna be rearranged and then come here. Then if it comes here, meaning it's gonna affect also this hydrogen. And then since this was the one hydrogen, and then here it comes with what? It comes with CH2, meaning it's gonna be CH2 and then plus with this hydrogen. That's why we're having what? We're having CH3. Okay, so meaning we're going to have CH3 there, and then we're going to have CH3 below here. Even if this was on this side, or even was this side on your left, ne? Below on your left, you're gonna also take one carbon here and then put it here with whatever hydrogen that will be formed in this compound. So even if our CH3 CH2 was this side, we're gonna have the rearrangement of CH3 gonna come this side, right? Regardless of the positioning of your branches. I hope you understand. Do you have any questions so far? Because I think the 4 organic reactions, they end here on the rearrangements.
Yes.
Is it a question?
Mm.
Yes.
Why do we have arrows with different length? Why do we have those arrows with different length?
On the what?
The arrows that shows direction of the reaction.
Yeah.
Mm.
I'm not really sure, but I think it's because of the stability of the reaction, how it will take place. Because maybe if the reaction, when it will form this product, or it will have this kind of a reactant to form this certain product under the certain catalyst, ne, is gonna be faster as compared to this reaction as your reactant, and then forming this as your product. That's why I think that's why maybe they have shown that here it's shorter, and then here it will be longer. I think maybe that's the case.
So if it's long, it means already the reaction will take place at the start.
The what? I can't hear you properly.
If
Someone is making noise that side. I don't know whether it's you or what, because the mic is on. I don't know this person. Ayanda, switch off your mic. You can continue.
if again we have a longer arrow, again, it means the reaction will take place at a faster rate.
I think so.
Right.
I think so. So do you have any question?
Mm-mm.
Anyone? Guys, this were the four organic reactions. So meaning you all understood since you don't have questions. And then here they're saying that the substitution reaction are typically saturated. This is very much important. You must know that they are saturated compounds such as the alkenes, such as the alkyl and the aromatic compounds. You have to know that where normally the substitution reactions they are going to be found, they're going to be typical for the saturation of the alkenes, the alkyl and the aromatic compounds. And then with the addition we already talked about it. They're typical for the double or the triple bonds, right? And then also the elimination since it's the opposite of the addition, it gives us the method for preparing the compounds with the double and the triple bonds. Okay, so meaning if we can check the two, they are more opposite to each other, the addition and the elimination. And then the rearrangement, you all know that is just the rearranging of the certain atoms or the compounds. Reps, I see your hand is up. You can talk.
Okay, so is it safe to say the substitution reactions are single bonded? Is it safe to say that?
Yeah, I can see. You can say that because they're basically the alkenes, right? So they are
Yeah.
not the alkenes or the alkynes. Are you still with me?
Yeah.
So do you get it?
Yes.
Okay. So I hope here we are done. And then now we're moving to the concept of the nucleophilicity and the electrophilicity. The nucleophile and the electrophile, in short. Basically, the nucleophile name is a molecule or a substance that has a tendency towards to donate the electrons or to react at a electron poor site such as the protons. So normally the nucleophiles, they are produced in the formation of the acids and the bases. They have the tendencies of what? Of donating the electrons. Whereas the electrophile is an atom or a molecule that in a chemical reaction, it will contain the electron pair available for the bonding. So normally in the Lewis acids, we're saying that the electrophile, it will what? It will accept the electron pairs. Ne? That's the electrophile. So here they're saying that the organic compounds except the alkenes, they have one or more sides They have one or more sites that can be identified as either the nucleophilic, which is denoted by Nu, and then they're saying it's negative, right? Then or the electrophilic, which is denoted by letter E, which is positive. One can understand and predict a given reaction by identifying these reactive sites, meaning that they're gonna give you the reactions, right? The reaction sites, and then they ask you the question whether is this nucleophilic or is this electrophilic. So it's your responsibility to check at your electrons or at your compounds, and then be able to know, is this nucleophilic or is this electrophilic. So in this case, they have given you the nucleophilic reagents. Can you see them? The nucleophilic reagents, remember, the nucleophilic, they are Nu, then which is negative, and then they have a tendency of what? Of donating the electrons, right? All atoms with the partial negative charge, it is denoted by nucleophilic. Negative ions, the double bonds between the carbon atoms, and also the lone pairs of the electrons. So I see nitrogen here. Nitrogen is having lone pairs. Yes, it has lone pairs of electrons. Then also we're having hydrogen here. And then they said that the double bonds between the carbon atoms, we're having the double bonds where there's a double bond between, this is not between the carbon atoms, it's between carbon and oxygen. And then here we're also having the lone pair of electrons. Then also here, then they also denoted the what? They included the negative charge ion here. Can you see it? So all atoms with a negative charge, they will be classified under the nucleophilic agents. All the double bonds between the carbon atoms, meaning if we have a compound whereby it has the double bonds between the carbon atoms, it will also be form part of the nucleophilic agents. And whenever we also have the lone pairs, you know what is a lone pair? When you are drawing your Lewis structure, né? Lone pairs of electrons, those lone pairs, we're also going to classify them under the nucleophilic nucleophilic reagents. So do you all understand? Okay. We're having the electrophilic reagents. So the electrophilic reagents, we said they do what? They do accept the electrons. Okay, from the background or the knowledge of the acid-base theory, the electrophile, they do accept the electrons. The electron deficient sites, they include what? Atoms with the partial positive charge. They don't have much of the conditions, unlike the nucleophilic reagents. But these ones, they have the atoms with the partial positively charged, and then also the positive ions. This is obvious, right? Atoms with partial positive charge and atoms with positive ions. So if we can check, we all know that carbon is positively charged, right? So on my example here, I only see the arrows which are directed to carbon. Which are directed to carbon atom. So in this case, it will be what? It will undergo the what? The electrophilic reagent. So do you all understand? And I think like today we're going to end here because these ones of mechanism of organic reaction, they need the fresh minds. These ones of the rules, they need a fresh mind, and I'm also tired, you see. So I think today we're going to end here because even on the time limit it says 5 minutes left, because you know that Zoom, it has a limit of 40 minutes, right? So I had someone saying that I should repeat. So can we can we wait for these 5 minutes to elapse? Then if you feel like you didn't understand well, I will repeat the part of this. I think it's only this part of electrophilic and the neutrophilic, right? Yes, so you can come back using the very same link, join it again, and then I will repeat. So others who understood, they can just leave the session and then not come back. I will only explain the electrophilic reagent and the neutrophilic agent because there is someone indicated that he didn't understand. So the relation from here, from the relationship to acid and base and the mechanisms, we're gonna do them, I think, tomorrow. Yeah, I think tomorrow late, yeah. And then we'll be done. If we do mechanism of all these things and the examples, then they're not that much, just that they need a fresh mind, so that we can understand the differences. So now you must go and digest whatever we did today, the reactions, and also the relationship between the neutrophilic and the electrophilic reagents. And then tomorrow I think we will have another session, and then we will continue from the mechanisms, whereby we're going to learn how to shift our electron shifting, because this mechanism will occur throughout when you're going to also do the chapter for alkenes, alkynes. So the mechanism will be everywhere. So if you don't get the mechanism here, meaning it's gonna be difficult for you throughout. So the mechanism is very much important. It's just that you guys are lucky this year because you're writing online. But if you are not writing online, it's gonna be something else, because you are supposed to have maybe a structure like this, whereby you're going to indicate how your electrons are moving or how are your electrons shifting. And if it happens that you miss one step or you don't indicate that shifting of electron, meaning is going to be a wrong. Your whole reaction is going to be wrong. So, but it's very much important to know how to draw it, even if it's multiple choice. I know that they're just gonna bring different structures. So, if they bring those different structures, be able to know which one is going to be correct, depending on the shifting of those electrons. Okay. So you have to know all the processes and your whole mechanism. So those who are doing SHE, I'm not sure whether you are also doing these things or what, because you might find that you are grasping the wrong knowledge. SHE students, are you also doing these things? Because I believe somewhere are here. Yes, so guys, the session will end now. So if those who still want the explanation will come back, and then others, good night and thanks for attending.